Welcome to our channel. In this session, we will move to the concept of best to first search algorithm. Remember, we already covered different algorithms like BFS, breadth to first search algorithm, and DFS, depth to first search algorithm. Those two algorithms follows uninformed search, that is blind search. Now, coming to this best to first search, it uses some heuristics to find out the goal node. Now, what the algorithm is simply, it maintains one open list. Anyway, either in BFS or DFS also, we are maintaining open list. This open list consists of all the unvisited node. Whenever we explored a node, all the successors are placed in the open list. Here also, it maintains the open list. But the thing is, in best to first search algorithm, the values, that is the nodes in the open list, are in sorted order. So this sorting order is the heuristic value, means this algorithm maintains the open list sorted based on the heuristic value. Now what happened? Instead of exploring all the nodes, or instead of blindly exploring the nodes, we are explore the nodes that have best heuristic value. Got it? Why? If you are placing in sorted order, automatically the node with the best heuristic value is at the head of the list, and we do pick up that particular node from the head of the list and do the remaining operation. Now you got it? So the main thing is the nodes in the open list are sorted order based on heuristic value. Now we will implement this one by considering this example. The example is almost similar to BFS and DFS. If you observe carefully, create two empty lists. One is open and another one is closed. You know the meaning. Open is used for exploring the nodes, and closed list is used for if a node is already visited, to avoid revisiting of the node. The visited nodes are placed in the closed list. That is the reason I am using two lists. Now, first step. What is the first step? The root node. That is initial node is placed in the open list. And remember, here make sure that your open list is in ordered. Simply, the open list is in sorted order. Means whenever you are adding a new node, the node is added based on the heuristic value. That is, the position of the node is based on the heuristic value. Anyway, the first node is placed into the open list. Now, what is the procedure? Simply, we are repeating the process. Suppose if the open is empty, means there is no element in the open list, and go stop the process and return false. That means the goal node is not reached. The goal node is not reached. Now, if the open is not empty, means the open consists of at least one element. Then what you need to do? Select the first node from the open. Once you are selecting any node, that is that node is visited, immediately the visited node is placed in the closed to avoid revisiting, and then capture the information of the parent node. And the thing is, whatever the node we visited, suppose if that is the goal node, the node you are visited is the goal node, means your search operation is successfully completed. Simply we are returning true and backtracking the path. To get the solution, you are moving to the back path and the answer is completed. Suppose if the selected node is not the goal node, then what you need to do? Simply expand this node. Whatever the childs are available, all the children node are placed in this open list. Again, do the same procedure from the open list. If you are using DFS, the last inserted node is the first selected. If you are using breadth first search, the first inserted node is selected. But here, by placing the chain nodes, we are selecting the node which has the best heuristic value. You got the point? The only criteria is selection of the node based on the best heuristic value. Okay. Here the main thing is heuristic. Now, this best first search have two variations. One is greedy best first search. Another one is a search star. What is the difference between those two? In this first approach, it uses only the heuristic function h of n to estimate the distance from the current node to the goal. That means right now, I am at this position. This approach, what happened? Direct distance to reach the goal node. It calculates only the distance to reach the goal node. That is calculated. Okay. And the main thing is it prioritizes the nodes that are closest to the goal. But a best first search algorithm, instead of directly reach the goal node, it consider the actual travel cost, that is g of n plus h of n. What is the meaning? H of n is the direct distance. Along with the direct distance, it also calculates the cost for traveling. I think you got the point. For example, A to B to C, if this is, suppose in greedy approach, it just to observe, this is the direct distance, I am using this path. Assume this cost is 20, this is 5, this is 10. A search algorithm, along with the distance, it also consider the cost. Compared to 20, 5 plus 10, 15 is the better one. You got it? If you want to move from one city to another city, generally both the methods do the same procedure, that is visiting the next city. But the difference is in the greedy approach, it just to distance, but it does not consider what is the actual road, that is the road conditions, is any curves are there, any hills are there, everything is not considered. But in a search star algorithm, it consider the efficient route mapping. I will explain with one example. See this one. If you are traveling from city S to city E, both the algorithms suggest the route, but different considerations. See, in greedy BFS, it chooses the next city. While reaching from S to E, in between some cities are there. It chooses the next city based purely on the closest city to E according to the heuristic value. So simply blindly select the nearest city. But in a search star algorithm, select the next city by minimizing the travel cost. You got the point? Depending upon your requirement, you can use any of the approaches. Now, if you are using greedy method, simply focus on heuristic distance. If you are using a search method, you are calculating both the costs, that is total cost along with estimated cost. Now, I will explain this one with one example, then you will get some clear idea. Now, suppose this is the graph. What is the graph? Starting is S tends to AB, A tends to CD, B tends to EF. Now, all are reached to goal. Okay, these are the different nodes. And H of n presents the heuristic value of each and every vertex. Here, my assumption is lower heuristic value is the best one. First, observe how this algorithm appear. Open, close. Initially, the starting vertex S is placed in the open and closed is empty. Now, what is the first step? The first step is expand S. If S is the goal node, the answer is completed. But S is not the goal node. Then expand S. So, what are the children's to S? A, comma, B. Now, my open consists of the expanded nodes A, comma, B, and closed consists of already visited node S. Now, if you are using DFS, you are selecting the last inserted node. If you are using BFS, you are selecting the first inserted node. But here you are using best to first search. Then among A, comma, B, which one you need to consider? A has value 4, B has value 5. I said better, lower value is the better one. So you are selecting the node with lowest value. That is A is selected. Now in the next step, you need to expand which node? You need to expand node A. Now open is equal to already B is there. Now what are the childrens of A? C comma D, and then closed is equal to now what the closed consists of? Already S is there, now A is also there, A comma S. Now goal is reached or not reached? Not reached. Now among B, C, D, which one is selected? B has a value 5, C has value 3, D has value 2. So simply select the node D. This has the best heuristic value. Now expand to D. Now my open consists of B, C, and D is already picked up, and G is added. My closed consists of D, A, S. In the next iteration, in the next step, B value is 5, C value is 3, G value 0. Anyway, we are selecting node G. In the previous step only, G is the goal node. Here also we are selecting the G. G is the goal node. Means once your goal node is reached, stop the process. Clear? Each and every iteration, select the node which has the best heuristic value. That is the concept. Here, from this example, what are the observations you made? Simply, it select the lowest heuristic first. That is the thing we are happened up to now. Here, it does not necessarily find out the shortest path because it ignores the actual cost. That means in this example, I am using only h of n value. That means actual cost to traveled is ignored. So obviously it does not necessarily find the shortest path. Suppose if the heuristic value, any mistake in the heuristic value, obviously it mislead the solution. It mislead the solution. Now, what are the advantages? Compare it to BFS and DFS. Instead of blind brute force approach, it is some faster. Why? It uses heuristics. If the heuristic is good, automatically the algorithm is also good. And it may not be optimal. If the heuristic is 4, you are stuck at some position. It uses lot of memory. This is the best to first to search algorithm. That's the end of today's session. Thank you.